Hi. As Emmett said, we're Hugh Hunt. We're the advanced intern team, and we're going to be telling you about all the cool stuff we did this summer and a little bit of what we did last summer. So Hugh Hunt is a puzzle platformer about a young boy who goes out into the world to restore color after his dad accidentally zaps it away in the process of trying to create him a new color so he can use in his science project. You go around the world solving puzzles using your trusty light beam, and it's meant to teach kids in a 3rd to 5th grade range the physics principles of light. My name is Isabel Merced Galindo. I'm this team's designer. I also did some project management. I did some level design. I'm currently attending the University of Southern California to do game design. So really living the dream right now. So this is our 2nd summer back. So the first summer we made a game just like all the lovely prototypes you saw today. And we were asked to come back to take it from prototype to polish. So what did that really mean for us? Well, we didn't have an idea because we were the first team to do this. So we had to set goals for ourselves. We knew that one of the things we wanted to do was definitely expand on what we had done last year. So take our levels, make them longer, add some new content like new friends, some new languages that we feature. We also wanted to polish, which meant updating some of the art, patching any bugs that happened because there were bugs that happened last year. We also wanted to reinforce our teaching goals, which meant that visiting our client more often. It meant adding some more educational content that was really explicit so kids understood exactly what vocab they were being taught, and also just making sure that our game was tutorialized, which basically means that if our game was like a board game, the instructions already came included, which isn't necessarily something that every game has. So we wanted to make sure that our game had a very fleshed out instructions manual so people could have it and play it. Some of the science that we aim to teach, and it's some of the science that was in our game last year, was reflection, refraction, and dispersion. Here are some trusty diagrams to help any refreshers on this physics of this, but essentially all of our levels teach a different physics principle of light. Red is for reflection, blue is for refraction, and green is for dispersion. So up first, our tutorial. This is an entirely new level that we made this year with the aim of just teaching you exactly what you need to know in order to play. As a designer, one of my jobs is creating situations where the player is encouraged to do things, but we never want to force them because kids are supposed to be learning. So one of the ways that we encourage players to do all the things on that task list that you see up there is place obstacles in their path. For example, you can see highlighted in 1 or in pink, a box. So this box doesn't hurt you. It just stands in your way from talking to your dad, who's highlighted in 2. So in order for the player to learn how to jump, they want to go talk to dad, which you'll see in a trusty cutscene at the beginning of our tutorial. We establish an emotional bond between our protagonist, the kid, and our client, the dad who is based off of our client, the dad character in our game. So the player is motivated to jump over the box to go talk to dad. We have different task lists in our tutorial level. The first one being essentially how you move around and interact with the game. And then the other one showing you some of the science concepts you'll see early on, like mirrors and water, because those are the types of things that your light beam can interact with and do interesting things with.
Hi, everyone. My name's Axis. I use any pronouns. I go to Mount Holyoke College, where I am a psych major, English minor, and I did the illustrations for this game. Clicker. Yay. So as Isabel mentioned, our character and his dad are based off of our client and his son. And our client really wanted the dad to be the villain and for his son to overthrow him at one point. And we were like, I don't think we can do a fight scene, but we can make you a problematic character. That's achievable. So the first level that we returned to and revamped was our red level. Each level is based around a different color, except for the tutorial, which is grayscale. And each level is supposed to have 3 things: a mechanic, a critter, and a language. The mechanic for the red level is reflection. You shine a light at a reflective surface and it bounces back at a different angle, and you try to figure out what angle to touch these certain crystals with. And if you can touch the crystal, you can teleport to them. And we had this from last year, but something that we added this year was last year, our red level was the only one that didn't have a funny little animal in it. Very disappointing. And so we felt that we needed to add a funny little guy, and we started talking about what kind of animal do we want to put in this level. It takes place in a volcano, so it's not like there's a lot of animals that are indigenous to volcanoes we could take inspiration from, but we had the idea for a mini game we wanted to add that involves manipulating rocks. And we were like, we don't have to use a real creature. We can use one from mythology. And so I'm Jewish, and in our mythology, we got these little guys called shamirim, which are little bugs that eat rocks. So we added Shlomo the Shamir and his family to help you out by eating the rocks for you. And since each creature in the level speaks a different language that you have to use your database to translate, Shlomo speaks Yiddish because it was either that or German. That's all I can bring to the table. And it made more sense to give him Yiddish as a Jewish little guy. And I asked my professor to check my Yiddish translations. So that was a fun conversation to have. Here, Joshua. Clicker.
Hi everyone, my name is Joshita Muthakrishnan. I use she, her pronouns. I graduated from NC State last year with a BS in Computer Science Game Development, and I was the programmer on Hue Hunt this year. I worked on gameplay and animation programming, as well as some of the user interface design. Our red level from last year was pretty solid in terms of gameplay and mechanics, but we decided to give it a minigame in order to expand on its educational content. The main goal of this minigame was to teach players what makes surfaces reflective. We also wanted it to be easy to pick up and play, which meant that the user interface and controls had to be intuitive to players. It needed to be fun and silly, because we wanted it to match the rest of the tone of our game. And since we had limited time, we needed to make it in a week. So what does make surfaces reflective? Basically, the smoother they are at the microscopic level, the better they reflect light. We needed to give the players some way to turn a rough, spiky, non-reflective surface into a smooth, shiny, reflective surface. What we ended up with was an arcade-style side-scrolling runner minigame, in which Slow Mini, the Shamir, moves from left to right on a spiky rock surface and bites the spikes off the rock. The player can control her chomp size to eat the spikes, and they can only eat a spike if her chomp size is big enough. There are 3 options that you can toggle between using the keyboard keys or the mouse. And the smallest chomp can be used infinitely, but chomps 2 and 3, the medium and large chomps, have cooldowns, so they can't be used when they run out of charge. To better explain what that means, here's a little GIF of the red minigame in action. Basically, the current chomp is highlighted in yellow, and when a chomp runs out of charge, the next highest chomp is automatically selected. Adding cooldown timers to the larger chomps was an intentional design decision on my part. Its main goal was to stop players from endlessly using the largest chomp to eat every spike, but it also adds an element of strategy to the minigame, as well as rewarding quick reactions. But there isn't much of a penalty if the chomp isn't big enough. Shlomini only gets knocked back a little bit before continuing onwards. Next up is our blue or refraction level. In this level, the player is taught that light bends when going from air to water, and they can use the end of their light beam to direct a catfish to solve puzzles. When we got to reworking our blue level, we decided to add walkie-talkie messages plus diagrams from the player character's dad, which are used to explicitly describe the optical phenomena that players encounter, such as reflection, refraction, and dispersion. These are meant to be non-intrusive, so players can continue playing the game as the messages are displaying, but they're also informative since they introduce players to technical terms if they choose to read the messages. So how did we come to the conclusion that we needed these walkie-talkie messages in the first place? We don't just make up the things that we need to do. We're interested in knowing what our players think. So we went through a series of tests called playtesting. Essentially, what this means is we're just assuring the quality and the usability of our product by having someone play our game, and we observe and we take notes. These notes for our team were organized into four columns: feedback, issue, solutions, and severity. For example, one of our common feedbacks in our blue level was that people were saying verbally, "Why isn't the fish following my light?" Which we concluded the issue was that it wasn't clear to the player that the fish was following the end of the light beam, not the whole beam itself. It was only following a certain point, kind of like how a cat follows a red pointer. So we had to make that clear to the player. So our solution, or a fix that we could implement, was to highlight the endpoint of the light beam using a pulsing circle. We decided that this was a pretty severe issue, so it would rank pretty high, probably like a 5. And the way that we decide how high ranking an issue is based on how consistent the feedback we get is. Like, if a lot of people are saying it, it means it's probably a prevalent issue. We also see how relevant it is. If it's stopping our player from enjoying the game or from understanding the education, it's a pretty relevant issue. But if it's something like they just minorly didn't enjoy a sound that they heard, we can put that pretty low priority as like a 1. We also see how hard would it be to implement the proposed solution and see how big the reward would be. So if something is super hard to implement, but the reward would be very great, we could put that pretty high up there. We concluded after tons of playtests with friends and family, which, by the way, special thanks to my family. It helps a lot to have people who don't understand video games to play video games, to understand how usable games for kids are. And we concluded after this series of testing that we weren't reaching our teaching goals and we weren't reaching our tutorialization goals, which are things that we wanted to return this summer to improve. So you'll see up there that there's a before of what our puzzle used to look like. It was pretty complicated and there were tons of mirrors and, things weren't really ironed out and the solution wasn't very clear. This puzzle could be solved in so many different ways that it became really confusing for players. And also, this is the only part in blue that you actually shined your light into water. So not great to throw a really hard puzzle at someone first thing they come into the level. So what we did is we added a smaller puzzle at the beginning of the level that you'll see highlighted in a pink 1. And that's to just show to the players that they can guide a fish over to a button in order to lift a platform up. And then in the after, you'll see that we simplified that big puzzle from before. So there's not multiple solutions, but it still has you scratch your head a little bit and think about what you need to do to get the fish over from one end of the puzzle to the sombrero that you're supposed to acquire in order to give it to our special friend in that level, a frog.
All right. So last year, green was the level we got to last, and we only had 1 week to work on it. And as a result, it was ugly. So this year when I was coming back, I was like, as the artist, one of my main goals is we need to redo the green level because right now it looks like a giant booger. Much better. Now there's more contrast. We also had these little monkey characters and that we redesigned. And unfortunately, something that was lost transitioning from last year to this year, the monkeys are no longer on skateboards. I'm sorry. But that's because most of the level is now actually within a temple and the monkeys aren't zooming around. Instead, they're mostly there at the beginning to help you get into the temple, which Isabel is going to tell you about.
So yeah, as Axis mentioned earlier, our green level was done completely from scratch this year. There wasn't many polishing things to do. We just wanted to remake it. And the reason why we wanted to remake it is because we wanted to introduce the idea of dispersion into our level. And the main idea with dispersion that we wanted to introduce is that different colored lights bend differently. So in order to make that clear to our players, we wanted a puzzle where the solution was that you had to realize that different colored lights bend differently. But as a level designer, just because I have the solution doesn't mean I know how to create a level that contains that specific solution. So I made a puzzle where there are 4 elements in it. There's an eye that you have to shine light into. There's a prism that you have to shine light through in order to get it to bend. And there's a pillar and a door, which serve as obstacles. The door needs all the eyes to be on in order to open, and the pillar blocks the player from just shining their light anywhere they want in the room to hit that prism. So there's a lot of variables here because on one hand, I want every single color to be used in this level. But in order for every color to be used, I have to give that player a purpose. I have to give that player motivation to use the different colors. Because all the colors bend differently, I needed the eyes to be in places where different bending would reach different different eyes. So that's a lot of variables. In fact, it's so many variables that when I first approached designing this level, I had no idea what I was supposed to be doing because there was no way to create that simple solution that I wanted players to see. So I took a step back from designing and I just made diagrams. I made diagrams that showed where Kiddo, our protagonist, could stand in order to reach different angles, to understand how positionality to the prism affected the level design. You can see here that there are like different cones coming out of the prism, and that's the entire range that the light beam can reach. So for red, that's all the places red can reach. And then green, that's all the places green can reach. And then in that last diagram, that's all the places that blue light can reach based on its refractive index, which is just a fancy way of saying how much it bends. So a lot of this optical geometry was really tripping me up, but this helped me take a step back and understand which variables I should be focusing on. I should focus on limiting the position of the player. I should focus on placing the eyes in the range of the different colors that I saw. And I should also restrict where the player could shine their light through. So that whole prism was going to be way too many angles to keep track of. So I should just have the player shine through one specific point in the prism. And this is the result. You can see here that the eyes are in range of specific colors, that the prism is restricted to just that one space where the player can reach. It's like open at the very right of it. And you can also see that the position of the protagonist is limited because 1, they can't shine from the left side of the prism because there's a wall there, and 2, they can't go through that door. So they're kind of they're motivated to stand in a space where they can achieve the results that I want them to achieve. We hope that Hue Hunt in its polished state can be used for outreach in middle and elementary schools because we understand that STEM outreach is extremely important. It's important to show that these light physics concepts don't have to be intimidating. They can be intuitive, they can be fun, they can be gamified. And we hope that our client, Nick Antipa, goes out and he uses this for outreach in his multiple programs because we worked hard on making sure that all the content is there. And we think that it shares a very important message. Again, we'd like to acknowledge our client, Nick Antipa. He's been there for every client meeting. He showed us what optical geometry even was, which was really helpful. We'd like to thank our coach, Emmett, for being with us 2 years. We'd like to thank Pamela Cosman for being the director. We'd like to thank Neil Smith for his help as well. And we'd like to thank the invisible presence in our office, Minnie, Axis's service dog. So you'll see all of our levels on screen, you'll see all of our names, and you'll see the question, or you'll see the statement, ask us anything.
So congratulations. I do remember this game from last year. It was amazing and it's even more amazing now. So well done. It sounds like you learned a lot having had this sort of second iteration to do everything with the polishing and all of that. But what are some of the things that you learned from last year, technical skills or otherwise, that you were able to bring forward or even carry throughout the year from last summer to this summer and beyond?
I'll do something like really quick and it's like very technical. I went to school for games and I learned how to use the software because I kind of came into this program the first summer knowing nothing and then went to school for games, learned how to use the programs, and that just helped me understand and communicate with my teammates better because I understood what from an art perspective was feasible. I understood way better now what from an engineering point was feasible because I had to code stuff myself, and that was helpful in just understanding what I was asking of Joshitha, and I was able to just speak the language. And I think in a team that's so small as ours, but also in how interdisciplinary we are, we had to be able to speak each other's languages. So from my standpoint, that was definitely something I was really proud of coming into this year, understanding and knowing.
I'd say there aren't any skills that I used last year that weren't relevant this year as well. You just had to, if anything, I had to add more of them. Nothing ever stops becoming relevant because you always end up having to go back and fix it and change it and debug it. Yeah.
Between the two internships, I'd say I learned the most about making UI that scales for different screen sizes and aspect ratios. I did not do that the first time around, and so it was a headache to get everything working better this year.
We got someone in the back, I think. There was someone at the back. Oh, sorry.
Hi all, fantastic presentation. I'm curious, what was the process for figuring out the math and physics behind the refractions, deflections, and implementing it? Because it's super impressive and seems very complicated.
I won't talk too much about this because Joshika definitely has the math, but I will say that we had some code last year, but we had to redo it this year because it was from a different programmer. So this, who was not with us, unfortunately, this year, but this year we remade it in Joshita.
Yeah, go Joshua.
Thankfully, people have already made the equations like Snell's law, and that determines, based on the refractive indices of two media, how much a light is going to bend. So I didn't have to do anything too hard that way. The issue was combining that with the structures that Unity provides to you. So that was a little complicated. I can probably talk more about it after the presentation because it's like 500 lines of code.
I think there's one in the front.
Yeah, a question from the live chat. So, why did you decide to add a mini game in Level Red specifically?
I know that we were really proud of Red from the first year, so we felt like if there was, that's where we started last year, and that's where we started this year. So we felt like if there was anywhere to expand a lot in, we could start where we had the most solid foundation. And we knew that one of the things about our reflective level was that reflection's kind of really intuitive already. So we thought that we could expand a little bit more and explain why things reflect off the things that they do, which meant making a game for it because that's what we're in the business of.
I feel like you pretty solid covering.
Right. You know, let's hold the rest of the questions for afterwards. So thank you very much.